Hello, hello. So let's do a couple more problems here. Who's excited? I know I am. Oh, before we begin, let's start this video with a nice, excited, yay math? Yay math. Alrighty, let's do some math. Okay, if ABCD is a parallelogram, find the measure of angle C. So, first thing we want to do is solve for x, right? Alright. Since this is a parallelogram, one of the important properties is that the opposite sides are congruent. So we're going to be doing 13x minus 25 equals 9x minus 1. Okay, so this is a situation where you can, in fact, set them equal. They are not supplementary. Those are when they are consecutive. So like if this had been right here, then you add them and set it equal to 180. But they're opposite, and opposite angles are congruent. And then we just solve. So we're going to add 1. Actually, I'm not going to add 1. Just kidding. I'm going to subtract, oh dear, this 9x from both sides, because I'm going to make it positive. Do the other way, and it's not going to become positive, right? Right, okay. So, we're going to get 4x equals, and we're going to add, well, let's do 4x minus 25 equals, that canceled out, a negative 1. So then we can add 26 to both sides. Okay. And what am I saying? I'm sorry. I need to focus on what I'm doing. I'm looking at these dogs here, and they're just so cute, and I just want to pet them, and also stop licking that. Hey! Okay, I'm focused now. So we're adding 25 to both sides. Sorry. Then that's going to become a nice 24. 4x equals 24. Divide both sides by 4, so x equals 6. Okay, and then make sure that you go back and plug it in. Let's use a nice and different color. So we're going to do 9 times 6 minus 1, so that's 54 minus 1, which is, you guessed it, 53 degrees. Okay, that's for the measure of angle C. Now, it might have asked you to calculate the measure of angle D or something. Well, in that case, once you get this, you need to subtract from 180 to get that other one. All right, but that's not what we're asking for here, so we're done. Easy peasy. Okay. Oops. All right. So for number 11, you might want to get out some highlighters or colors or something, because whenever it starts to give you these angles, it's going to be really helpful for you to know what angles you're referring to, so you can kind of highlight and go over what you're trying to solve. So we are given the measure of x, y, z. All right, so I'm going to highlight x to y to z so we can see that that entire angle is, as they tell us, 68 degrees. And then wxz, so here's w to x to z, is 71. So there's that right there. Okay, very good. So we want to find the measure of wzx. So let's just go over that. W z x. Boom, boom, boom. Okay, so that's what we're trying to find right there. All right, so this is a parallelogram, meaning a couple of important things. The first thing you should know is that the consecutive angles are supplementary. So consecutive means the ones right after one another. So if I were like traveling along this parallelogram, that's what consecutive is, one right after the other, and they are supplementary. So that means that z and y are supplementary. They add up to 180. So the first thing I would do is subtract 68 from 180, right? And that's going to give us the entire measure of angle z. Okay. Oops. All right. So we get angle z is 112 degrees. That whole angle there, right? This whole angle here. Okay. Well, since this is a parallelogram, we know that alternate interior angles are congruent. And so I have a pair of alternate interior angles here. Right? So this 71 is also 71 down here, okay? And then I just calculated that the entire angle Z is 112. So the next thing you're going to do is 112 minus 71. And that's going to give us 41 degrees. So that's my answer. Ta-da! Okay? Okay. Cool. Didn't get that? Well, just rewind it and watch again and pay closer attention. Okay? Okay. The next one, if XZ is, so these are talking about segment lengths, not angles, right? Yeah, there's no degrees like on the last one. They had degree measures there. So since we're talking about segment lengths, let me erase all this. Okay. Then we're going to have to, we're not doing anything with 180 or anything like that. We just have to figure out, well, do I set them equal? Do I have to multiply anything by 2? That's what we want to figure out. So if the entire diagonal here is 8x minus 18, but then it tells me that RZ, which is only this portion of the diagonal, is 2x plus 5, find XR. So the equation that we're going to use is RZ right here is going to be half of the entire length. A property of parallelograms is that the diagonals bisect each other, meaning XR is congruent to RZ, right? But it doesn't give us XR, it gives us XZ. So what we want to do is take the whole length of XZ, 8x minus 18, and set that equal to twice the length of RZ. Or for those of you that divided the entire diagonal by 2 and set that equal, that also works. Okay? But I would just say in general it's easier to just, because some numbers might be odd, and when you divide by 2 you don't want to get a decimal. So we can set them, set up that equation 2 times RZ. And then we're just solving, right? You guys can do that from there. Do I need to do that for you? Fine. Distribute the 2, bring everything else down. Oops, sorry, that's a negative. 18, okay, we're going to minus 4 from both sides. Add 18 to both sides. So 28 equals 4x. Divide both sides by 4. Oof, divide that. Okay, so x is equal to 7. However, that's not my final answer. It wants XR. Okay, so guys, XR is just this part of the diagonal, which, as I already said, is congruent to the other part of the diagonal. So we want to just basically plug it into RZ. 2 times 7 plus 5, so that is 14, plus 5, so that's 19. Okay? The entire diagonal then would be 38, but it only wants XR. Cool? Cool. All right, let's move on to 13 and 14, which are about this rhombus here. What is the measure of DHG? An important property of rhombi is that, as we already talked about in the other videos, rhombi have perpendicular diagonals. So the angle there formed in the middle is a right angle, meaning it's 90 degrees. That's all. The end. Moving on. All right, so, but that's going to help us solve this next part. It says if DGE, so DGE is 42 degrees, find FDE, so FDE. Okay, so let me label that. DGE is 42, so that's this angle right here. Let me make this a little smaller. This is still 90 degrees here, and we are looking for this angle here. Now, because this is a rhombus, another important property is that the diagonals of a rhombus bisect opposite angles. Well, how is that helpful? That means that whatever this angle is here has to be the same as the one right next to it here. So essentially, if I find this angle, it's going to be my answer because those two are congruent. So as you can see, we have this lovely right triangle here. Oh, how nice, this right triangle that I'm highlighting. And we know one of the angles is 90 and the other one is 42. So all that's left is to add the 90 plus the 42. So I'll do that right over here. 90 plus 42, which is 132. And then we want to subtract that from 180 because all the angles of a triangle will always add up to 180. So my answer is 48 degrees. Because this angle here would be 48, and so would the one right next to it, which is what we're asked to find. Okay? And that's it. Easy peasy lemon squeezy. Okay, how many did we do there? Alright, I'm going to pause right here, and we'll do the rest of them in another video. Yeah, let's do that. Cool!